Crocodilians are known to be some of the most formidable predators in the world today. In fact, it's estimated that there are over 200 species of crocodiles and alligators living today, and some of them are absolute units. But crocodiles today are nothing compared to some of their relatives that lived back when the dinosaurs roamed the earth. There was one particular crocodile relative that was absolutely massive and walked on two legs like a human. That animal is called Batrachopus grandis, and we have fossilized footprints that tell us all about it. So let's take a look at this two-legged crocodile relative and try to answer the question, how big did it get? Hi, and welcome to Paleologic. Today, we're going to be talking about the gigantic two-legged crocodile relative called Batrachopus grandis. Before we get into the animal itself, we need to talk about what Batrachopus grandis actually is, because it isn't an actual animal. It's more like a type of rock. Okay, so in science, fossils can refer to anything preserved in rock from an ancient environment, not just bones or shells or teeth. So things like footprints, burrows, gastroliths, which are these little stones that some animals would eat to help with digestion, or even poop. These are all types of trace fossils. The specific fossil we'll be talking about today is a type of ichnotaxon. If you don't know what that is, don't worry, because I didn't either. Basically, an ichnotaxon is a type of trace fossil that's been given its own name because it's so distinctive that it helps scientists tell it apart from other types of similar fossils. And the ichnotaxon we'll be talking about today is called Batrachopus grandis. Batrachopus grandis is a type of fossilized footprint that's been found in the Korean Jinju and Hayman formations. The tracks were made during the early Cretaceous about 125 million years ago, but the tracks weren't left by some sort of dinosaur. Instead, they were left by a crocodilomorph, which is an outdated term for any kind of crocodile relative. Most of the Batrachopus tracks were made by small land crocs that were about the size of a dog, but occasionally the tracks were left by much larger animals. And those large tracks have been grouped together under the name Batrachopus grandis. In total, there are 17 giant Batrachopus tracks that have been found in Korea. They were left by a bipedal crocodilomorph that walked on the tippy toes, kind of like a human or a bird does. So far, we haven't found any skeletal remains of this particular animal, but based on the tracks, we can estimate how big it was and how fast it could move. The thing is, though, when you find fossilized footprints, it can be hard to figure out which direction the animal was walking. Sometimes it's obvious, like if the animal was running away from something and the footprints are all facing in the same direction. But in many cases, paleontologists can't be sure which way the animal was facing. To get around this problem, scientists use something called a thin section to figure out the orientation of the tracks. Essentially, this just means cutting a thin slice off of the rock and looking at it under a microscope. If the thinnings show signs of water flow, then you know which direction the animal was walking. Unfortunately, though, water flow is absent in the Batrachopus grandis tracks, so scientists had to rely on another method to try and figure out the direction the animal was walking. They looked at the shape of the footprints themselves. Many animals walk with a slight rotation of their feet, so the shape of the print will reflect that. If the heel of the foot doesn't sink in very far, but the front of the foot does, then the animal probably walked with a slight rotation. If the opposite is true, then the animal probably walked without rotating. So based on the shape of the prints, it seems like this giant crocodilomorph was walking with its feet rotated outward, kind of like a crab claw. This also means that the animal was likely walking in a quadrupedal stance, meaning it used 4 legs to walk. Some people may say, wait, didn't you say that this animal walked on 2 legs? And that's true. However, scientists think that this animal spent most of its time walking on 4 legs, but it could stand up on 2 legs when it needed to. Think of it kind of like a bear. Bears spend most of their time walking on 4 legs, but they can stand up on 2 legs if they need to. Now, unlike bears, this crocodilomorph had longer hind limbs than forelimbs, so it would have looked kind of like a kangaroo. So now that we understand what kind of animal we're dealing with, let's get back to the question we posed in the intro. How big did it get? Well, to answer that question, we need to take a closer look at the tracks themselves. The fossilized footprints tell us two important things about the animal that made them. First, we can measure the length of each stride to figure out how long the animal's legs were. Second, we can compare the size of the footprints to modern animals to get a sense of how heavy the animal was. For example, scientists know that American alligators have relatively small feet compared to their body size. So if we find footprints that are the same size as an alligator's feet, then we know the animal that made them weighed about the same as an alligator. Or, if the footprints are twice the size, then we know the animal weighed twice as much as an alligator. So by comparing the size of the footprints to modern animals, we can get a rough estimate of how heavy they were. Scientists used both methods to estimate the size of the giant Batrachopus. They measured the length of each stride and compared the size of the footprints to modern-day animals. Using these two pieces of information, they came up with an estimate of how tall and heavy this crocodilomorph got. Based on their calculations, this giant crocodile relative reached lengths of up to 3 meters and weights of up to 600 kilograms. That's about the size of a polar bear, except it walked on 2 legs. And while we're on the topic of comparisons to modern animals, it's worth mentioning that the closest living relatives of this bizarre beast are the Philippine crocodiles. That's right. The weirdest crocodile relative from the time of the dinosaurs is most closely related to the goofy-looking crocodiles found in the Philippines today. But despite being related to crocodiles, this animal wasn't a fish eater like most of its relatives. Tooth replacement patterns in crocodilomorphs are really consistent. Most species start out with baby teeth that fall out and are replaced by larger teeth as the animal gets older. But this was not the case for the giant Batrachopus. The giant Batrachopus never developed teeth as an adult, so scientists think it was probably a carnivore that ate meaty prey. Now, one of the reasons that this animal is so strange is because crocodilians today are mostly aquatic. Most species live in rivers, lakes, or coastal areas where they can easily access fish. And many species, like the American alligator, are pretty good at climbing trees. But this animal was adapted to life on land. Its head was elongated, kind of like a dog's, and it had smaller, more rounded teeth, which is typical for a terrestrial animal. Because of this, scientists have traditionally classified this group of crocodile relatives as archosaurs. Archosaurs are a diverse group of reptiles that includes crocodilians, dinosaurs, and pterosaurs. Some archosaurs were adapted to life on land, like dinosaurs, while others were adapted to life in the water, like plesiosaurs. But this animal was neither. It was basically a mix between an aquatic dinosaur and a terrestrial crocodile. But unfortunately, this strange beast wasn't the only predator that shared this niche. Another animal that also walked on 2 legs and lived during the time of the dinosaurs was the bird. That's right, birds are technically dinosaurs. And during the age of the dinosaurs, there were many kinds of theropods that were about the same size and shape as this crocodile relative. Theropods hunted using their sharp teeth and claws, and this would have been pretty effective if they hadn't been competing with this guy. Over time, the pressure from these 2-legged dinosaurs would have led to the extinction of the Batrachopus, and today we only know about them thanks to their fossilized footprints. If you enjoyed learning about this strange 2-legged crocodile relative, then make sure to subscribe. We make videos about all kinds of cool stuff from the world of paleontology, and you don't want to miss out. Also, a huge thank you to our supporters who make videos like this one possible, and a special shout out to our top-level supporters. You guys rock. Anyways, that's all for this week. As always, this has been Paleologic, and I'll see you next time.